In today's video, we are looking at nuclear fission, which refers to the process of splitting a large and unstable atomic nucleus into smaller, more stable nuclei, and at the same time releasing a significant amount of energy, which is the fundamental source behind all of the nuclear energy we currently harness here on Earth. Nuclear fission can occur in two main ways, either spontaneously, which means it happens entirely on its own without any external influence, or by the absorption of a neutron, which causes the already unstable nucleus to become even more unstable, thereby splitting it apart. In practical scenarios, spontaneous fission is relatively rare, which is why in nuclear reactors we initiate fission by bombarding the nuclei with neutrons to get the entire process underway. To understand how this works in more detail, let's walk through the steps. We begin with a large and inherently unstable nucleus, such as uranium-235, and then we fire a slow-moving neutron at it. This neutron is absorbed by the uranium nucleus, making it so unstable that it splits into two smaller nuclei, known as daughter nuclei. This reaction also releases 2 or 3 more neutrons along with a substantial amount of energy in the form of gamma radiation. These released neutrons can then interact with other uranium nuclei and trigger more fission reactions, leading to the release of even more energy neutrons and daughter nuclei. This cycle forms what is known as a chain reaction, where each fission event causes subsequent fissions to occur. If this chain reaction is not regulated, it can accelerate uncontrollably and result in the rapid and massive release of energy, which is precisely how nuclear bombs operate. However, in nuclear reactors, this process must be tightly controlled to ensure safety and efficiency. The rate of fission is mainly managed using control rods, which can be inserted into or removed from the reactor core to absorb excess neutrons, thereby slowing down or speeding up the reaction as necessary. The energy produced by the controlled fission reaction is used to heat water, turning it into steam, which then drives turbines connected to electrical generators, producing electricity for widespread use. Now let us talk about the advantages and disadvantages of using nuclear energy. On the positive side, the fuel such as uranium or plutonium is relatively inexpensive and capable of producing a consistent and large amount of energy. Although nuclear energy is not classified as renewable, it is considered a clean source of power because it does not emit greenhouse gases like carbon dioxide, which are produced by burning fossil fuels. However, there are notable downsides. Building a nuclear power plant requires a tremendous financial investment due to the complex technology and safety systems involved. Additionally, the waste produced by nuclear reactors remains radioactive for a long time and is extremely costly and difficult to dispose of, as it must be safely buried deep underground in specially designed containment facilities. There is also the persistent concern about the possibility of a catastrophic failure at a nuclear facility. While modern safety protocols make such events highly unlikely, the potential consequences are severe enough to make many people wary of nuclear energy. That brings us to the end of this video, and we hope that you found the explanation clear and informative. If you did, please consider giving us a like and subscribing to our channel for more helpful content, and we will see you in the next one.